Good morning, students. Welcome to our physics class. In the last classes, we discussed what is an electric current. What is an electric current? Yes, electric current is the flow of charge in a given time. That is I equal to Q by T. What is the unit of electric current? Yes, ampere is the unit of electric current. Then we discussed what is potential difference. Potential difference is the work done in moving a charge from one point to another point. Okay, so what is the equation to find a potential difference? Yes, V equal to W divided by Q. What is the unit of potential difference? Volt. Another name of potential difference is voltage. Okay, the potential difference is given by the cell or battery or the output from a generator. Clear? So, using this electric current and the potential difference or voltage, Ohm, a scientist, a physicist, Ohm derived a law. That law is called Ohm's law. Ohm's law. So, Ohm's law is related with electric current and potential difference. Electric current and potential difference. Okay. Then what is the definition of Ohm's law? Ohm's law states that at a constant temperature, the condition of Ohm's law is at a constant temperature V proportional to I. Ohm's law is related with the potential difference V and electric current I. Okay, so Ohm's law states that at constant temperature or at a fixed temperature, potential difference between the terminals of the conductor is directly proportional to the applied electric current. Okay, what is the meaning of directly proportional? When potential difference increases, when voltage increases, current also increases. Okay, for example, we consider a circuit diagram. What is a circuit diagram? Yes, circuit diagram is the continuous and closed path of electric current. Okay, so we consider an electric bulb. It is the symbol of an electric bulb. This electric bulb is connected with a switch open or plug key open. Then a battery, here is ammeter. Battery of 3 volt. Okay. When switch is on, what happens? Electric current passes through the circuit. Electric current flows. And bulb glows. Okay. So here we connected 3 volt battery. When 3 volt battery is connected to this electric bulb, what happens? When switch is on, electric bulb glows. Okay. Then we replace this 3-volt battery by 6-volt battery. What happens? More electric current passes through the circuit and bulb glows more brightly. Bulb glows more brightly. Why? Potential difference increases, electric current also increases. First, we connected 3-volt battery. So, electric current proportional to this 3-volt battery passes through the circuit and bulb glows. Okay. When 6-volt battery is replaced here, instead of 3-volt, 6-volt battery is connected. Electric current proportional to 6-volt passes through the circuit and the brightness of the bulb increases. Brightness of the bulb increases. That is called Ohm's law. At a constant temperature, V proportional to I. In the case of Ohm's law, we can draw a graph. X-axis, Y-axis. This point is called origin. Here is current. Current drawn along the X-axis, and potential difference or voltage is marked along the Y-axis. In the case of ohmic conductor, in the case of conductors which obeys Ohm's law, the VI graph is a straight line graph. We get a straight line graph in the case of Ohm's law. If a conductor satisfies Ohm's law, such type of conductors are called ohmic conductors. Okay. In the case of ohmic conductors, or in the case of Ohm's law, V is directly proportional to I. V is directly proportional to I. That's why the graph is a straight line. We get a straight line graph, or we get a linear graph. Clear? This is called Ohm's law. Then next we can explain different equations related with Ohm's law. So here V proportional to I. V potential difference. V means potential difference between the terminals of a battery. So this is called potential difference. Okay, potential difference means PD. PD means potential difference. This potential difference between the ends of a conductor is directly proportional to the electric current flowing through the circuit. V proportional to I. Okay, so here is a proportionality sign. Okay, if we remove this proportionality sign, we can write V equal to constant into I. Okay, equals, or V is equal to constant into I. Clear? We can write this constant, or this constant is called resistance of the conductor. This constant is called resistance of the conductor. So we can write, or V is equal to a constant. That constant is represented by a letter R. This R is called resistance of the conductor. R into I. So we get one equation. Or we can write V equal to IR. V is equal to IR. Clear? Okay, this is called Ohm's law. Ohm's law, V directly proportional to I. V is equal to constant into I. This proportionality constant is called resistance of the conductor. Okay, this proportionality constant is called resistance of the conductor. This resistance of the conductor is represented by letter R. So we can write V is equal to Ri or V is equal to IR. Clear? Okay, from this equation we get different types of equations. For example, from this equation we can write I equal to R is given to this side, V divided by R. Another equation, I equal to V by R. Next, R equal to I is given to this side, V by I. So these are the equations related with Ohm's law. These equations are very important for solving different problems in the case of Ohm's law. Okay, so what is Ohm's law? At constant temperature, potential difference between the terminals of a conductor is directly proportional to the electric current flowing through the circuit. Okay, that means when potential difference increases, current also increases. When potential difference decreases, current also decreases. What are the equations related with Ohm's law? V proportional to I, first equation. V proportional to I. Second, V is equal to IR, Ri, or V is equal to IR, or I is equal to V by R, or R is equal to V by I. These are the different equations related with Ohm's law. Then here we know what is the unit of current. Unit of current is ampere. Okay. Unit of potential difference or voltage is volt. We discussed in the previous class. Okay. Unit of electric current ampere. Unit of potential difference or voltage is volt. Then what is the unit of R? What is the unit of resistance? We know this resistance is related with Ohm's law. So Ohm is the unit of resistance. The SI unit of resistance is Ohm. SI unit of R is Ohm. It is the symbol. Ohm. The symbol of Ohm is this is the symbol of Ohm. Ohm is the SI unit of resistance. So we can define what is 1 ohm. What is 1 ohm from this equation? 1 ohm equal to 1 ohm is equal to 1 volt divided by 1 ampere. This is the definition of 1 ohm. 1 ohm is equal to 1 volt divided by 1 ampere. So what is the meaning of resistance? Resistance means it opposes. Resistance means opposes the flow of electric current. Okay. Resistance means opposes the flow of electric current. When resistance increases, flow of electric current decreases. Clear? So resistance means if 1 volt of potential difference is applied across the terminal of a conductor, 1 ampere current flows. That time we can say resistance is equal to 1 ohm. Clear? So this is about Ohm's law. Clear? Just we can revise. What is Ohm's law? Yes, at a constant temperature, potential difference between the terminals of a conductor is directly proportional to the current flowing through it. So what is the condition for satisfying Ohm's law? At constant temperature. Okay, then in the case of Ohm's law, the graph shows like this. Graph is a linear graph. We get a linear graph. Okay, so here in this experiment, when 3 volt is applied, bulb glows. When 6 volt is applied, electric current increases accordingly. So brightness also increases. These are the equations related with Ohm's law. Clear? Next we can explain about resistors. Okay. So resistor, what are the factors which depends on resistors? Resistance of a conductor depends. Resistance of a conductor depends, number 1, length. Number 2, area of cross section. Number 3, temperature. Number 4, nature of the material. These are the factors which depends on the resistance of a conductor. So, resistance of a conductor depends length of the conductor. Number 1, length of the conductor. Number 2, area of cross section. Number 3, temperature. Number 4, nature of the material. So, length of the conductor is represented by a letter L. Area of cross section is represented by a letter R. Okay. Then we can explain in detail how length and area of cross section depends the value of resistance. Okay, so we can write resistance of a conductor is directly proportional to its length. Resistance of a conductor is directly proportional to the length of the conductor. Resistance of a conductor is inversely proportional to area of cross section. So we can write, combining these two equations, we can write R directly proportional to L divided by A. Resistance of a conductor is directly proportional to the length of the conductor and inversely proportional to area of cross section. This is called law of resistance. This law is called law of resistance. Law of resistance states that resistance of a conductor is directly proportional to its length and inversely proportional to its area of cross section. Clear? Okay. Then we can write different equations related with law of resistance. So the equation is R directly proportional to L by A. Next, R is equal to constant into L by A. This constant value is called resistivity. What? This constant value is called resistivity. It is represented by a symbol rho. RHO. This symbol is called rho. It is the symbol of resistivity. So we can write R equal to rho. Rho is the symbol of resistivity. Rho into L by A. So we get another equation. R is equal to rho into L by A. What is R? Resistance of the conductor. Rho, resistivity of the conductor. L, length of the conductor. A, area of cross section. Area of cross section. Clear? So the resistance and resistivity of the conductors are different. Okay. So resistance means it is the opposition of the flow of electric current. We know there are different types of conductors. Okay. Examples. What is the meaning of conductors? Conductors are the substances which allows the electricity to pass through them. Okay, such type of materials are called conductors. For example, metals, iron, silver, copper, gold, all are the examples for conductors of electricity. But the resistance and resistivity of the conductors are different. Okay, resistance and resistivity of the conductors are different. In the case of nichrome, nichrome means the high resistance wire. Copper, low resistance wire. Silver, low resistance wire. Iron, high resistance wire. So the resistance of the conductor varies, or resistance of the conductor depends nature of the material. Nature of the material means, in the case of iron, nature is different compared to copper. In the case of copper, nature of the material is different in the case of compared to gold or silver. So nature of the material differs. That means the resistance of the conductor also varies. Clear? So what is the equation to find the resistance of a conductor? R equal to rho into L by A. From this equation we can find an equation for resistivity. So we can write rho equal to A is multiplied with R. So RA divided by L. Resistivity. To find the resistivity of a conductor, we can use this equation. What is the equation? Resistivity rho equal to RA divided by L. Then what is the unit of resistivity? Unit of resistivity. Unit of resistance ohm. Unit of area meter square divided by unit of length meter. Meter cancelled. So what is the unit of resistivity? Ohm meter. Ohm meter is the unit of resistivity. So the resistance of a conductor depends 4 factors. What are they? Length of the conductor, area of cross section, temperature, and nature of the materials in which the conductor is formed. What is the meaning of law of resistance? Law of resistance states that resistance of a conductor is directly proportional to its length of the conductor and inversely proportional to area of cross section. So we can write this equation. Okay, R proportional to L by A, R equal to constant into L by A. This proportionality constant is called resistivity of the conductor. Resistivity of the conductor is represented by a symbol rho. Okay, so R equal to rho into L by A. From this equation, we can find an equation for resistivity. So R is equal to RA by L. What is the unit of resistivity? Ohm meter. So using these equations, okay, we have to solve many problems in this chapter. Okay, so today we can conclude our class. Okay, thank you.